So we're going to look at ordering whole numbers and decimal numbers. This video is especially aimed at those of you struggling with understanding the size of decimals. My main reason for this is that whilst most people are generally happy with ordering whole numbers, decimal numbers can prove to be more of a challenge. I'm going to look at how I go about ordering numbers. I'll begin with whole numbers, then move on to decimal numbers, and then finally we'll look at a set of numbers and place those in ascending order. I will be going through this in a rather slow and pedantic way. Hopefully this will become clearer when looking at decimal numbers. Let's begin with whole numbers. We're going to look at pairs of numbers by comparing their digits to determine which is the larger of the two. We will begin by comparing the numbers 20 and 19. Now you probably know that 20 is bigger than 19, but let's write them down anyway using the base 10 grid, so that the digits in the numbers line up. We now compare these two numbers by looking at the digits reading from left to right, because the place value of the digits gets larger the further left we go. We can see that for these two numbers, the first column we are comparing, reading from left to right, is the tens column. Now 20 has two tens, whereas 19 has one 10. That's it. We don't have to compare the numbers any further to tell us which is the largest of the two numbers. Two tens is bigger than one 10, so 20 is bigger than 19. Or you can say that 19 is smaller than 20. Now let's look at 460 and 459. Again, you probably know the answer. We'll begin by lining up the digits with the hundreds, the tens and the units. Starting from the left, in this case we are beginning with the hundreds column. We can see that both numbers have 4 hundreds. Both numbers are effectively 400 and something. Now let's look at the tens column. We see that 460 has 6 tens and 459 has 5 tens. OK, we don't need to compare the numbers any further. 6 tens is greater than 5 tens, so we can say that 460 is bigger than 459. Now let's compare 234 and 237. Again, we begin by lining the digits up, the hundreds, the tens and the units, and start comparing. Starting from the left, we compare the hundreds. We can see that both numbers have two lots of hundreds. OK, so let's compare the tens. We can see that both numbers have 3 tens. Well, let's move on and compare the units. We can see that 234 has 4 units and 237 has 7 units. Since 7 units is bigger than 4 units, 237 is bigger than 234. And finally, let's compare 341 and 67. Although one number has 3 digits and the other number has 2 digits, this doesn't affect what we do. Again, we begin by lining the digits up in their correct columns, the hundreds, the tens and the units. Starting from the left, we begin by comparing the hundreds. We can see that 341 has 3 hundreds. With 67, although there isn't anything written here, it basically means that there are no hundreds. Let's just put a nought in to show this. Well, 3 units is bigger than 0 units, so 341 is bigger than 67. But you probably knew that. The beauty is that when ordering or comparing the size of decimal numbers, this approach is no different. It just is a continuation of what we've been doing, except we are comparing the digits after the decimal point. Let's compare decimal numbers. 0.2 and 0.1. Let's line them up using the base 10 grid, reading from left to right, starting with the units. we can see that both numbers have no units. OK, so let's compare the next column, which is the tenths column. So 0.2 has 2 tenths and 0.1 has 1 tenth. Since 2 tenths is bigger than 1 tenth, 0.2 is bigger than 0.1. Let's look at 2.69 and 2.7. We line them up using the base 10 grid, reading from left to right. Starting with the units, we can see that both numbers have 2 units. OK, so let's compare the next column, which is the tenths column. So 2.69 has 6 tenths and 2.7 has 7 tenths. Since 7 tenths is bigger than 6 tenths, 2.7 is bigger than 2.69. We don't have to compare any other digits. We could have had 2.6999999 recurring. It would still be smaller than 2.7. Now let's look at 56.85 and 56.846. Let's line them up using the base 10 grid. I'm going to go through this example more quickly. We can see that both numbers are 56 point something. So let's immediately focus on the digits after the decimal point. Reading from left to right, we start with the tenths. Both numbers have 8 tenths. OK, so let's move on to the hundredths. We have 56.85, which has 5 hundredths, and 56.846, which has 4 hundredths. Since 5 hundredths is bigger than 4 hundredths, 56.85 is bigger than 56.846. We don't need to compare the numbers any further. I want to point out at this stage that when comparing decimal numbers, the number of digits after the decimal point doesn't necessarily determine the size of a decimal. Let's look at a couple of examples to further illustrate this. If we look here, we have 0.2 and 0.199999999 and so on. We can add as many 9s to 0.19 as we like, but it will always be smaller than 0.2. We can see that both numbers are less than 1 because they are 0 point something. So when we start comparing the digits after the decimal point, beginning with the tenths, we see that 0.2 has 2 tenths, whereas 0.19 recurring has 1 tenth. So 0.2 is going to be bigger than 0.19. And if we look here at 0.84912 and 0.84896574, God knows why I chose those as an example, we can see that both numbers start 0.84, but when we get to the thousandth column, we see that 0.84912 has 9 thousandths and 0.84896574 has 8 thousandths. Therefore, 0.84912 is the bigger number. So when I'm ordering numbers, I'm quickly glancing at them from left to right, comparing the digits. But let's put this into practice. Here's a set of decimals, and we need to place them in ascending order. Now you can have a go at this if you want. Just pause the video, and when you've ordered them in ascending order, press play for the answer. OK, so this is what I do. I'm going to begin by looking at the numbers that are less than 1. So these are the numbers that begin 0 point something. Here they are circled. I immediately see that 0.42 has 4 tenths, whereas the other numbers have no tenths. So 0.42 is the largest of these 3 numbers. And I can see that 0.019 has 1/100th, whereas 0.03 has 3/100ths. So the smallest number is 0.019, followed by 0.3, and then 0.42. Now let's deal with numbers that are less than 10. More accurately, numbers that are less than 10 but greater than or equal to 1. There are 2 numbers here, 3.761 and 5.13. Well, 5 units is bigger than 3 units, so these numbers in ascending order are 3.761 and 5.13. Now for the remaining numbers, we'll order those that are less than 100. We have 4 of these here. I can immediately see that the biggest two numbers are 45 point something, and this is bigger than 28 point something. But there are two which are similar, 12.491 and 12.52. So they are 12 point something. So let's begin by comparing the first digits after the decimal point. That is the digits in the tenths column. Well, 12.52 has 5 tenths and 12.491 has 4 tenths. So 12.52 is the larger number. So in ascending order, we have 12.491 and 12.52 and 28.1, 45.607. This, of course, leaves us with 156.846. So here are the numbers in ascending order. So this is a brief glimpse into how I order a set of numbers. Hopefully this has been of some help to you, especially if you struggle with understanding the size of decimals. I will be revisiting decimal numbers in the future. But that's it for now, and thank you for watching.